All right, let's talk. This is a fun attack, and it shows a weakness of hash algorithms. Now, you've probably done this, we all have, whether you know it or not. When you download a big thing, like a movie, you get this file that might be 5 or 10 gigabytes, and then you might calculate the hash to see if you got it. Well, you can't fit all that in your memory, typically. So hash algorithms do not rely on having the entire contents in memory. In fact, they work on blocks. You hash a block of input, then you hash the next block of input and the next block of input and add it into the hash you already have out there. All current hash algorithms work this way, although I'm not sure about SHA-3, but anyway, most of them work this way. And what that means is you can pull dirty tricks. Here's a website that I set up to demonstrate this. This is a website where you can log in. If I log in with Joe, username Joe and password Joe, it sends in an authentication cookie. And the cookie is a cryptographic signature showing that it can trust the data that came in with Joe. Cookie authentication is correct. And that's based on a shared secret key, a secret key that's in this web page and also in the server. So the point is this page uses MD5 hashes and a secret. So when Joe logs in, a cookie is set. This is an MD5 string with a secret phrase. It takes the secret phrase and then it adds the username equals Joe to it and it hashes that. This is essentially how signature works. And so this proves that this data here is correct and that you are in possession of the secret because it matched. The problem is, since you can extend hashes, I can now forge a signature from a signature that exists. The intention of the designer is this is not a secret. It's sent over the internet. But if you know the signature that proves that you're Joe, you should not be able to create a signature that proves that you're somebody else. But in fact, you can, because this much data is hashed to that. I can add more data to the end and hash it on top of this hash and generate the hash, even though I don't know the secret. This is the problem with this construction. If you have the secret and then the data, then I can add more data to this hash and the secret is in there. That's why a simple solution is what you should do is have data and secret on the right of it. And then adding more stuff will not work. But this is a very common flaw. It's happened in a lot of systems. And so what you do here is you start up Burp, you get the login traffic, so you've got this cookie, although it's also visible on the page anyway. You don't really need Burp for this, but you get that data. And then there is a tool called Hash Extender that does this for you. It will now add additional data to it. You have to get it from getting a few, add additional data to your cookie. So the current data is username equals Joe, and here's the current signature, and I'm going to add and username equals administrator to it. So this is another flaw that a lot of websites have. If I go here, it's going to have username equals Joe, and I can add another username after it. There's a technical term for this. You'll find it in that Web Application Hackers Handbook. I think it might be parameter pollution, where you define the same parameter twice. You have username equals Joe, and then later on username equals administrator, and it's not defined by any RFC what should happen. So some websites will take the first one, some will take the second one, some will combine them together, but a lot of websites will just take the second one. At this point, it'll parse through this string. At this point, it'll set the username to Joe, and when it hits it again, it'll just take the variable and override it again with administrator. So I can forge a cookie that has all of this information followed by username equals administrator, and the hash has been changed to match that. And that's the trick. You can do that with hash extension. So it's pretty cool. You forge a cookie with this, and this is your new string. Username equals Joe, a bunch of extra junk, and way at the end, username equals administrator. And so if you send that data up, this is what you need Burp for. You need to replace the cookie with this longer crafted cookie, and then you'll be successfully logging in as the administrator. This will fool a lot of systems. Anyway, I wanted to point out that one to you as another example of the kind of mistakes you get from the subtlest error in your cryptography. All right, I'm going to stop this video.